In the previous lecture, we discussed the rules of dominance to reduce the size of the payoff matrix. In this video, we will look for the one example problem to solve the payoff matrix by applying the dominance rules. Let's see the problem. Using the principle of dominance, solve the following game. Here, player A having the 3 strategies and player B also having the 3 strategies. Let's see the solution. First, we check the saddle point of the game by mini-max and maxi-min principle. First, we determine the minimum value for all the rows. For the first row, minimum value is the -2. For the second row, minimum value is the -1. For the third row, minimum value is the 2. Among these minimum values, we have to select the maximum value. Here minimum values for each row are the -2, -1 and 2. Among these values, we have to select the maximum value. That will indicate the maxi-mini value. Here maximum value is the 2 and this is the maxi-min value. Similarly, next we have to determine the mini-max value. For this, first we have to determine the maximum value for all the columns. For the first column, maximum value is the 3. Second column, maximum value is the 4. Third column, maximum value is the 6. Among these maximum values, we have to select the minimum value. This is the mini-max value. Here, maximum values for each column is the 3, 4, 6. Among these values, minimum value is the 3 and 3 is the mini-max value. And here, mini-max value equal to 3 and maxi-mini value equal to 2. And mini-max is not equal to the maxi-min. So, given payoff matrix is not having a saddle point. Next, apply the dominance rules to reduce the payoff matrix size. Then solve the payoff matrix. First, apply the dominance rules for the rows. And we know that if all the elements in a row, that is XR, should be less than or equal to the corresponding elements of any other row, that is YR, then we have to delete the row XR. So first we have to determine the summation of all the elements in each row and write as row total. So first row total is the 3 minus 2 plus 4. Then the row total value is the 5. And second row total is the -1 plus 4 plus 2. This is the 5. And third row total is the 2 plus 2 plus 6. This is the 10. Among these values, 5 is the least one. Then select the first row. Then compare all the elements of the first row with the other rows such as second row and the third row. First we have to compare the first row elements with the third row because row total is maximum for the third row. Here first row elements are the 3, -2 and 4. Third row elements are the 2, 2, 6. Then you have to check the condition. XR is less than or equal to the YR. Here XR is the first row. Then first row all the elements have to compare with the third row. Here third row is the YR. Let us consider. Here we have to compare all the elements of the XR row is less than or equal to the YR elements. Here we have to compare the first row elements with the third row elements. So first element is the 3 in the first row. Similarly, first element in the third row is the 2. So 3 is not less than the 2. So condition is not satisfied. Here condition is all elements should be less than the other row elements. So first element in the first row, that is the 3, and the first element in the third row is the 2. So 3 is not less than the 2, that condition is not satisfied. Next we have to check the second row elements. So here first element is the 3 and second row first element is the -1. So 3 is not less than the -1. Then we have to go for the another one. Next we have to compare the second row elements with the third row. Here second row elements are the -1, 4, 2 and third row elements are the 2, 2, 6. So first I have to compare the first element in the second row, that is the -1, with the first element in the third row, that is the 2. So -1 is less than the 2. Okay. Next we have to compare with the second element in the second row with the second element in the third row, that is second element is the 4. In the third row is, so second element is the 2. So 4 is not less than the 2. So condition is not satisfied. Similarly, next we have to check the second row elements with the first row. Here first element is the -1. Then -1 is less than the 3. But second elements 4 is not less than the -2. So condition is not satisfied. Finally, we have to check the third row elements with the first row and second row. Here first element is the 2. Similarly, first element in the first row is the 3. So 2 is less than the 3. But second elements 2 is not less than the -2. So condition is not satisfied. Next, similarly, we have to check the third row element with the second row. Here 2 is not less than the -1. So condition is not satisfied. So here we can't able to remove the rows. Next we apply the dominance rules for the columns. We know that all the elements in the column, let us consider xc, is greater than or equal to the corresponding elements of the another column, let us consider yc. Then we have to remove the column xc. For this, first we have to determine the sum of all the elements in the each row and write as column total. So first column total is 3 -1 plus 2 is the 4. Second column total is the -2 plus 4 plus 2 equal to the 4. Third column total is the 4 plus 2 plus 6, it is the 12. Among these values, maximum value is the 12 for the third column. So we have to select the third column. Then we have to compare all the elements of the third column elements with the another column elements such as first and second column. Here third column elements are the 4, 2 and 6. These elements compare with the first column elements, that is 3, -1 and 2. Here 4 is greater than the 3 and 2 is greater than the -1 and 6 is greater than the 2. So all the elements in the third column are greater than or equal to the corresponding elements in the first column. Therefore, column 3 is dominated by first column. Then you have to delete the column 3. Now, reduced payoff matrix is for the player A point of view 3 rows, that is the 3 strategies, but player B point of view only 2 columns, which means only 2 strategies. Next, to compare the first column and second column elements. So 3 is greater than the -2, but -1 is not greater than the 4. So condition is not satisfied. Here no row is dominated to the another row. Moreover, no column is dominated to the another column. Then the payoff matrix is the 3 rows and the 2 columns, which means 3/2 payoff matrix. This 3/2 payoff matrix we can be solved by graphical method. Now we solve the 3 by 2 payoff matrix by graphical method. In the previous lectures, we already discussed the graphical method to solve the n by 2 payoff matrix. First step is let y be the probability of selection of alternative 1 by player B and 1 minus y be the probability of selection of alternative 2 by player B. Second step is derive the expected gain function of player B with respect to each of the alternative of player A. For this, first we have to draw the tabular column, and first one is the A's alternative. Here player A having the 3 strategies. First we have to select the first strategy. Next column is the B's expected function. For this, we have to multiply the first strategy elements with the y and 1 minus y, that is 3 into y plus 1 minus y into the minus 2. So this is will become the 3y minus 2 plus 2y equal to the 5y minus 2. Next column is B's expected gain. Here we have to substitute the y equal to 0 in payoff function, then determine the gain value. Similarly, we have to substitute the y equal to 1 in the payoff function, then determine the gain value. First we have to substitute y equal to 0 in the payoff function, that is 5y minus 2. Here substitute the y equal to 0, then gain value is the minus 2. Similarly, you have to substitute y equal to 1 in the 5y minus 2 payoff function, then value will become the 5 into 1, 5 minus 2, it is the 3. Next, second alternative is the, so B's expected payoff function is the multiply the second column elements with the y and 1 minus y, then minus 1 into y plus 1 minus y into 4. This will become the minus 4 plus 4 minus 4y. Then payoff function equal to minus 5y plus 4. Then I have to substitute the y equal to 0 and also y equal to 1. Then the gain values will become the 4 and minus 1. And third strategy is, A's third strategy is the 3. And B's expected payoff function. Then I have to multiply the third row elements with the y and 1 minus y. That is the 2 into y plus 1 minus y into the 2. It is equal to the 2y plus 2 minus 2y. Then value is the 2. Here there is no y value. Then expected gain at y equal to 0 also 2, and similarly at y equal to 1 also 2. Third step is plot the gain functions on graph by assuming a suitable scale. Keep y values on the x-axis and gain values on the y-axis. So here on the x-axis keep the y values, that is y equal to 0 and y equal to 1. And on y-axis keep the gain values of the A's strategies. First strategy gain values are the minus 2 and 3. So we have to mark the minus 2 at y equal to 0 and mark the 3 at y equal to 1. Then I have to join these 2 points by a line, and this is the line A1 line. Similarly, mark the 4 at y equal to 0 and mark the minus 1 at y equal to 1 for the second strategy. And join these 2 points, give the A2 line. Similarly, mark the 2 at y equal to 0 and 2 at y equal to 1 for the third strategy. and join these 2 points gives the A3 line. Next step is the find the lowest intersection point in the upper boundary of the graph, that is the minimax point. So this is the upper boundary of the graph, and these points, point E, F, G and H are the intersection points. Among these intersection points, F and G are the lowest points. Then select the any point randomly. Here I am selecting the lowest point is the G. So, and the G is the minimax point. And step 5 is the observe the lines passing through the minimax point. Here 2 lines are passing that minimax point, that is the G. That lines are the A1 line and the A3 line. Then form a 2 by 2 payoff matrix. Here line A1 and A3 are passing through the minimax point, that is point G. Then consider the first and third strategies for a player A. Then form a 2 by 2 payoff matrix. Here we have to remove the second strategy. So through the minimax point, lines A1 and A3 are only passing. So second line, that is A2 line, so is not passing through the minimax point. Then we have to neglect the second strategy for the player A. Now payoff matrix will become the, so strategies, two strategies for the player A, that is the A1 and A3, first strategy and the third strategy. For the player B, first strategy and the second strategy. Now payoff matrix will become the 3 minus 2, 2, 2. Next we have to solve this 2 by 2 payoff matrix. So here let consider the P1 and P2 are the probabilities of selection of A1 and A3 alternatives for player A. Similarly, let us consider probability Q1 and Q2 are the probability of selection of B1 and B2 alternatives for player B. And we know the formulas for the determine the P1, P2 and Q1, Q2. Similarly, we have to determine the value of the game. These formulas we know. Here, now payoff matrix is the 2 by 2 payoff matrix. Let consider A11 value is the 3, A12. So first column and the, sorry, first row and the second column, that is A12 minus 2. Similarly, second row and the first column, A21 value is the 2. And second row, second column, A22 value is the 2. Then you have to substitute this A11, A12, A21 and A22 values in the above equations for the P1, P2, Q1, Q2. Then P1 will become the 2 minus 2 divided by 3 plus 2 minus half minus 2 plus 2. Then value will be 0. Then P2 is the 1 minus P1. That value is the 1. Similarly, you have to substitute the A11, A12, A21 and A22 values in the Q1 equation. We will get the 4 by 5. Then Q2 equal to the 1 minus Q1, 1 minus 4 by 5. Then Q2 equal to the 1 by 5. Next, similarly, we have to determine the value of the game. So here also I have to substitute all the values of the A11, A12, A21 and A22. Then value of the game is the 2. Then optimal strategy for A and B is given by, that is, so 0, 0, 1 for the player A. Similarly, for the player B is 4 by 5, 1 by 5, comma 0. So this is the solution, and thank you.